The scenario that we're representing today is one in which a fire has occurred at a data center. You can imagine that there may be multiple parties involved here. There's the manufacturer of the IoT sensor equipment that should have detected the fire. There's the manufacturer of the fire suppression system, here acting as an actuator. And there's the insurance company who'd like to know who's responsible. Is this a freak accident, or did the temperature sensor fail, or did the fire suppression system fail? Here, we're trying to determine who's accountable. And we're using a blockchain document to determine who's accountable. As soon as the temperature sensor has detected that the temperature has risen above a certain threshold, it should log this in the blockchain document. Once logged in the blockchain document, a smart contract should detect that the temperature has breached the threshold and cause the fire suppression system to activate. Here, what we're showing is that two systems that don't know about one another are integrated through the blockchain, and that the blockchain acts as a medium of orchestration. So, let's go ahead and look at how these things can be built in Sparkster's no-code platform. The first thing we're going to do is we're going to build the blockchain document where we want this information stored. This is really as simple as dropping a few fields on a page in a drag and drop fashion. We want to record the temperature value, we want to record the time that this occurred, and what sort of message that we've received. Next, we want to create a grid where we can see all the blockchain documents of this type in one place. And so, we're going to create a grid that's going to connect to the stream that represents that document. And again, we can do this visually. Now let's go ahead and create our first device. This is the temperature sensor. And we're going to be using the microbit onboard temperature sensor. The first thing we're going to do is create a cloud field called temp. The cloud field will allow us to collect the temperature data points. For example, if we want to visualize them in a dashboard. But we're also going to define the logic which will run locally on the board. Note that we only want to update the blockchain document when the threshold is breached. Otherwise, there's no need to send that information to the document. The key difference here is that we're sending information to the blockchain, not data. And by selecting the document that we defined earlier, we're able to see the three fields that we created. Great, that's it. Now we can deploy the device. Now let's go ahead and create our next device. This device is going to represent our fire suppression system. We're going to connect pin 0 to the control pin on the servo, and we're going to do that simply by drawing a line. Notice that a block appears representing that line. Now let's go ahead and define the logic for how this device behaves. The first thing we're going to do is we're going to register a command. A command is how we instruct the device to activate. And we're going to call that command start actuator. We may also wish to collect data about the status of this device. Has the fire suppression system been activated? Has it not been activated? What's the status of the device? And we can collect that using the status field. We'll come back to what we do with these cloud fields in a few moments. Next, we want to define a subroutine for what happens when the fire suppression system is triggered. So the first thing we want to do is we want to set the actuator to 180 degrees. Remember, this is a servo. We obviously want to update the blockchain document. So once we search for the blockchain document, we can set the message value to started fire suppression system, and the time is the current time. Now in our particular example, we're going to wait for 5 seconds and then switch off the fire suppression system, and we're going to represent that by moving the actuator back to 0 degrees. And again, we're going to update the blockchain document to notify that the fire suppression system has switched off. Finally, we want to make sure that the subroutine is called when the start actuator command is received. Nice and easy. And now we can go ahead and deploy this device. Now, let's bring all these components together. We're going to create a flow, and a flow is a visual way of representing a sequential or parallel set of operations. Flows can be orchestrated on edge nodes and can be thought of as analogous to a smart contract. So, in orchestrating our flow, we want our flow to begin when a new record is created in the blockchain document. We only want to trigger the actuator if there is indeed a fire. And that's where, using the if blob, we're able to specify that condition. And finally, we want to trigger the actuator using the command we specified before. It's that simple. And finally, since IoT is so synonymous with dashboards, let's go ahead and create a few. In this case, we're going to represent the temperature on a line graph, and we're going to represent the status of the fire suppression system on a radial gauge. And you'll see that we're able to build this entirely visually. And so after we've repositioned things and changed some of the border and other properties, we'll connect to the stream that we're receiving from the device. Specifically, we'll attach to those cloud fields that we specified when we created those devices. And here, as you can see, visually and quickly, we can attach those cloud fields directly to the gauges. And now, let's see our hard work in action. The microbit on the right-hand side represents the temperature sensor. As we pick that up and raise its temperature, you can see the servo responds. And now we can see the interfaces we've created. On the left-hand side, the dashboard that's collecting real-time data from the devices, and the right-hand side, the grid that's streaming data from the blockchain document. Here you can see that as the temperature is raised above 32 degrees, a record is added to the grid on the right-hand side, and the fire suppression system is switched on. Thank you all so much for being with us this afternoon. We hope you've enjoyed what you've seen.